Right. So first thing we're looking at here is this question. A line segment joins the points C -5 and 6 and D 7 and 2. The first thing is to calculate the midpoint of the line segment. Then B is to find the gradient of the line segment. And then C, they're asking for an equation of the perpendicular bisector of the line CD. Another line AB is parallel to CD and passes through the point 0, 1. Write down the equation of the line AB. So this is a nice question because it's actually covering everything that you need to do or you will have to cover under this topic, right? So to begin with, I always start by saying to identify your points. So we're going to write the point C -5, 6, and D, which is 7, 2. We're also going to label these X1, Y1, and X2, Y2, right? Because we want to state our formulas as you're working them out. So we're going to write here midpoint of CD, right? And if you remember, your formula is going to be X1 plus X2. Remember, the midpoint is our coordinate, right? So this is why the formula looks just like our coordinate. So you're adding the two x's or the two x values together, you're adding the two y values together, you're dividing that by 2. So what is x1? X1 is -5, x2 is 7 over 2, y1 is 6, and y2 is 2 over 2, right? Let me just work that out. -5 plus 7 is the same as 7 minus 5, so that's 2 over 2. 6 plus 2 is 8 over 2, right? And 2 divided by 2 is 1. 8 divided by 2 is 4, right? And automatically, that's it there. We finish with the first one, midpoint of line segment CD. Part B is asking for the gradient of the line segment. So part B, right? Again, I always keep every part, especially if you're going on a different page, I always write this back because I want to see it directly in front of me. So when I quote the formula, like the formula for gradient of CD is equal to y2 minus y1 over x2 minus x1. I could just look up and see the values that I need to substitute into the formula. All right, everybody okay with that? Right. So y2 is the value 2 here. Y1 is the value 6. Underneath here, x2 is 7. And this is a little tricky part where you'll find students making errors. This minus sign is part of the formula. It has nothing to do with the -5 that's on the minus sign that's on the 5. So I need to put this -5 in a bracket, right? So we don't make any mistakes with our sign. So what is going to happen is I'll get -2 I'm going to get, 2 minus 6, which is going to give me -4. And underneath here, I'll have 7 plus 5, because the minus by the minus there give me a plus. So I get -4 over 12. And that's going to give me -1 over 3. Yeah, give me a thumbs up if you're okay with that. Right, so that's the gradient. Part C now. Now, part C might seem a little bit intimidating. When I talk to some of my students that wrote the JAN exams, they had a little issues with this. It's not a difficult question. Determine the equation of the perpendicular bisector. The perpendicular bisector, what you need to understand about the perpendicular bisector is, 1, is perpendicular. And what we know about perpendicular lines? Perpendicular lines, the gradient is the negative inverse. In other words, the gradient of this perpendicular line and I can just use this little symbol here, right? That means perpendicular, is going to be change this sign. So whatever was the original gradient you have, you're changing the sign. So if it's negative, I'm going to put it positive. And then I'm flipping this number. So if it was 1 over 3, then it'll become 3 over 1. And 3 over 1 we know is 3. All right? Give me a thumbs up if you're okay with that. All right, so that's all we do there. You change the sign, flip the number. So if the number was 3 before, then it'll become negative or 2, right? Now, it's a bisector. So a bisector means it is passing through the midpoint, right? So perpendicular, we have to find the gradient of a perpendicular line. Bisector means you're going to get your x and y values supplied by the midpoint that you calculated in A. Now, you know when we want to find the equation of a line. The equation of a line the formula for that is y is equal to mx plus c. This is the more commonly used formula. Last week I showed you guys two different formulas. This is the more commonly used one. To use this formula, we need the gradient, right? And that gradient is going to be positive a third as you work out on top of here. And we need a point to provide x and y values. The point we're going to be using is the midpoint. Anybody remember what the midpoint was? I think it was 1 and 4. Get up here. 1 and 4. Right? So this is my x value. This is my y value here. So I simply write the formula. Y is equal to mx plus c. And I'm substituting this for m, this for x, this for y. Let's see what happens here. So we're going to get 4 is equal to 3 multiplied by x is 1 plus c. You work it out, that's going to give me 3 plus c, and then we solve for c. So c is equal to 4 minus 3, which is 1. Now we're going to rewrite the formula, which is y is equal to mx plus c, substituting values for m and c only. Yeah? Everybody all right to that? All right, cool. So I'll get y is equal to 3 is the value for m, and with 3x plus c is 1. This is the equation of my perpendicular bisector. Everybody cool with that? Yeah, give me a little thumbs up there. All right. All right, so the last one is another line AB is parallel. What do we know about parallel lines? Parallel lines have the same gradient. So this line that they're talking about, AB, is going to have the same gradient as CD, which is negative 1, 3. It passes through the point 0, 1. We need a point and a gradient to do the equation of a line. So this is going to supply my x and y values. And since it is parallel, the gradient is going to be the same, which is negative a third. So this is what we're going to be using in order to find the equation of AB. Everybody understand that? So D. So parallel lines have the same gradient. Right? So gradient of AB is going to be equal to the same negative or 2. Right? The point, what's the point? 0, 1 is going to supply my x and values. Right, so we put the formula, y is equal to mx plus c. Y, this is my y, this is my x. So y is 1, gradient is our third, x is 0, which is in our favor because anything by 0 is going to give us 0. So the constant is 1. And just like above, we're going to rewrite y is equal to mx plus c, only including the m and c values. So we get y is equal to negative a third x plus 1. Yeah, everybody all right to that? And that is our solution for this question. So we got midpoint to be 1, 4. We got our gradient to be negative a third. The equation of our perpendicular bisector was y is equal to 3x plus 1. And this here, our parallel line AB that passing through the point 0, 1 has an equation y is equal to negative a third x plus 1. Okay? And this is from the Jan 2025 paper.